Since the 19th century, vehicle propulsion has undergone significant transformations. Nowadays, internal combustion engines and electric engines stand out. However, rotary engines deserve attention. They are variants of combustion engines but operate more smoothly and efficiently. Mazda, a well-known automaker, is a major enthusiast of these engines. Recently, it introduced an innovative rotary engine. Some claim that it has the potential to challenge the entire electric vehicle industry. Let's explore more about this revolution proposed by Mazda in the automotive world. Chapter 1: The Simplicity That Revolutionized. The incredible story of Mazda's rotary engine began with the dream of a young German named Felix Wankel. In 1919, at the age of just 17, Felix aspired to create an innovative gasoline engine, despite lacking experience in internal combustion engine engineering. His intent was to conceive a straightforward engine capable of performing all stages of internal combustion, intake, compression, combustion, and exhaust in an innovative way compared to traditional piston engines. Felix developed a unique design that employed a rotating triangular rotor and a peanut-shaped chamber. After many years of dedication and obstacles, he and his team at NSU Motor Works succeeded in 1959 in creating a functional prototype of the rotary engine. This achievement caught the attention of several vehicle manufacturers, including Mazda. The president of Mazda at the time, Tsuneji Matsuda, recognized the potential of the rotary engine and aimed to apply this technology to distinguish Mazda and strengthen its competitiveness. Thus, Mazda entered into a contract with NSU Motor Works to develop the Wankel rotary engine for mass production. As a result, Mazda became known for creating iconic vehicles powered by the rotary engine, such as the Mazda Cosmo, RX-7, and RX-8. These vehicles provided a unique driving experience, thanks to high revs and smooth power delivery. Today, Mazda reintroduces this engine but with a different approach. Despite the differences from these previous models, this new version of the rotary engine brings notable improvements, becoming a promising energy source for the contemporary era. The new Mazda MX-30 REV features a single-rotor rotary engine, unlike the iconic two-rotor rotary engine in the previous RX-8 model. This design change may surprise enthusiasts accustomed to the power and responsiveness of two-rotor engines. However, Mazda directs its new rotary engine toward greater efficiency and sustainable mobility. The introduction of direct fuel injection into the combustion chamber represents a significant improvement, ensuring better fuel atomization and combustion, resulting in higher efficiency and lower emissions. This advancement signifies a significant evolution in rotary engine technology, addressing one of the challenges faced by previous models regarding fuel consumption and emissions. An additional innovation is the application of exhaust gas recirculation, EGR. This technology contributes to increasing efficiency, especially at lower loads and rotations, precisely by recirculating part of the exhaust gases into the engine. The EGR system reduces the need to maintain the engine temperature, resulting in fuel savings and lower greenhouse gas emissions. Additionally, it helps decrease the production of nitrogen oxides, harmful pollutants released during combustion. Even with just one rotor, engineers manage to optimize the engine's performance while maintaining control over fuel efficiency and emissions. This approach aligns perfectly with Mazda's vision for the future, seeking to balance the joy of driving with environmental responsibility. Currently, Mazda adopts aluminum side housings instead of iron. This adjustment contributes to reducing the engine's weight, making it lighter and more efficient. Furthermore, the application of a spray-applied ceramic coating enhances the engine's durability, reducing wear and friction. Another notable improvement is the wider apex seals, now with up to an additional 2.5 mm, representing a 25% increase. This modification results in greater resistance to wear, extending the engine's longevity and reliability. In summary, Mazda'S rotary engine journey is a story of perseverance, innovation, and commitment to the future of sustainable mobility. Chapter 2: The Engine. Despite the mentioned advancements, there's disheartening news for traditional rotary engine enthusiasts. Now, this type of engine is exclusively used as a range extender in the Mazda MX-30 REV, rather than being responsible for the direct propulsion of the wheels. The rotary engine spins a generator that produces energy directly for a battery or an inverter, which, in turn, powers the electric motor that moves the vehicle. This implies there's no direct mechanical connection between the engine and the wheels. Although this configuration allows Mazda to take advantage of the rotary engine's characteristics, such as its compact size and smooth operation, it may disappoint those who were expecting a direct return of iconic sports cars powered by this type of engine in the past. In the case of the Mazda MX-30 REV, the rotary engine acts as a range extender for the fully electric vehicle, not providing power directly to the MX-30 but generating electricity to recharge the battery or power an electric motor that propels the vehicle. However, there are exciting rumors and leaked patents related to the Mazda RX-9 concept. Indications suggest that the RX-9 may incorporate a three-rotor rotary engine along with an electric motor, suggesting the possibility of being a hybrid vehicle that combines the power of the rotary engine and the electric motor to drive the wheels directly. Chapter 3. However, a lingering question is how the Wankel rotary engine truly operates. The Wankel rotary engine, developed by Mazda, works similarly to a conventional piston engine but has notable distinctions. Instead of pistons, it utilizes triangular rotors mounted on a shaft. These rotors perform a circular motion within a special housing. The engine cycle begins when the rotor creates a space in the housing, allowing the entry of the air-fuel mixture. As the rotor moves through the housing, it compresses this mixture. Ignition occurs when two spark plugs ignite the already compressed mixture. During the combustion phase, the resulting explosion propels the rotor due to the expansion in the chamber. At the end of the cycle, the exhaust gases are expelled from the housing. This cycle continues, with each rotor performing multiple cycles in a single rotation of the shaft. A conventional four-stroke piston engine is composed of at least 40 moving parts, including pistons, connecting rods, valves, timing gears, and the crankshaft. In contrast, the rotary engine offers a remarkable reduction in the number of moving parts, as a single rotor has only two moving parts, the rotor and the eccentric shaft. Even with the inclusion of more rotors, as in a two-rotor rotary engine, the number of moving parts remains surprisingly low, totaling only 3 moving parts, the 2 rotors and the eccentric shaft. This design simplicity is one of the main reasons why many consider the rotary engine a revolutionary technology since its inception. The concept was so promising that inventor Felix Wankel received government support during the early stages of developing this engine. Similarly, the Japanese government supported Mazda in its efforts with the rotary engine, allowing the company to work independently to explore the full potential of this innovative technology. The reduction in the number of moving parts not only simplified the engine's construction but also offered various advantages, such as greater reliability and lower maintenance requirements. Furthermore, the smooth and high-revving operation of the rotary engine contributed to its reputation as an advanced and futuristic propulsion technology. An additional significant advantage of Mazda's Wankel rotary engine is its quiet and smooth operation. Unlike the piston engine, which completes the thermodynamic cycle in 720 degrees, the rotary engine performs this cycle twice as fast, in only 360 degrees. This, combined with the smooth motion of the rotor, allows the rotary engine to achieve incredibly high rotations while keeping engine vibrations at low levels. However, why did Mazda discontinue the production of this engine if it is so remarkable? Firstly, since adopting the Wankel rotary engine, Mazda stood out as one of the few automakers that persisted with this technology. While other companies gave up on the rotary engine, Mazda remained true to Tsuneji Matsuda's initial vision, keeping the dream alive with a dedicated team of engineers. During the development process, the project faced skepticism, even within Mazda itself, as many considered it costly. Nevertheless, the company continued to invest in solutions and continuous improvements, allowing the rotary